All righty. Hello, everybody. I think we've given enough time for people to join. We're glad you could join us. One thing we need to make note of, Randy, unfortunately, is not feeling well today, and so Rich Benner will be flying solo. But we've got great content all the same, focused on anti-patterns and the right way, well, some of the wrong ways to use T-SQL. So without taking up any more time, I'll pass it over to Rich.
Hi, welcome to the Antipatterns webinar. The idea of this webinar is to go through some common mistakes that we see. As consultants, we get brought in when there's a problem. So that's the primary the most of what we see is the issues. We see more than most. So we're going to talk about some of the common ones, why they're a problem and how you can avoid them. SQL Solutions Group. We're headed by Randy Knight, who unfortunately is unwell today. We do full project consulting, RDBA, and coaching. If you need anything, get in touch. A little bit about us both here. I've been a DBA for around 16 years now, performance tuning expert. I'm a senior consultant here at SQL Solutions Group. So we've split into three main sections. We're going to go through some anti-patterns that we see in T-SQL that might be baked into some stored procs and custom code, anything like that. Then we're going to go through obfuscation, which is, I'll explain a bit more at the time, but doing this basically makes troubleshooting harder. When you've got a problem, it makes the investigation to fix so much more difficult. And we'll go through why. And then a few other standalone objects you can see on the right here. We'll completely cover them as we get to them. Bear with me 2 seconds. Right. So T-SQL anti-patterns. We see a lot of select stars. Now, what this means is doing a select star on a table to return data to an application. When a developer is writing code, it seems like a good idea. I want to return everything from that table, and then I'll deal with it in the application. So select star from object, whether that's a table, a view, whatever. But then what is often needed isn't the entire table. They actually only want 4 or 5 of the 10 fields. But pull it all back, I'll deal with it in the application, is often the train of thought. Now, this can be bad for a few reasons. When you talk about supporting indexes for your queries, having to have all of your indexes covering all the fields is what you'd need if you keep doing select star, because you've probably got where clauses in there, right? You're not just dumping in the whole index. You're probably looking at an ID or a date time or whatever. If you were to only return the fields you need, then your indexes can be much slimmer. Only contain the columns you need. So, and that will save you on disk space, memory, disk I/O. By being slim like that, by just always selecting star, you're always returning a bunch of stuff. Probably you don't need it. It's much better to specifically declare the fields you need. I need the ID, I need the name, I need the date, whatever. Return exactly what you need. One of the reasons for that is your query that runs with a select star doesn't have control of the object that it's selecting from. So if it's a table, what happens if somebody adds a new field to it? You're going to be returning that, and you definitely don't need it because you don't know it's there when you're writing the query. What if that field is a large object? What if it's a varchar max? What if it's a text field? Somebody adds a description field, and suddenly you're pulling back a varchar max that you didn't know about, you don't need. It's better to be specific. It's the long and short of this. It's a trap a lot of developers fall into, and it just puts some extra strain on the system. And I'd bet SQL Server is one of the most expensive parts of your system, even when you just consider licensing and server costs. So yeah, be specific. Otherwise, you're going to fall into a raft of issues. Okay. Another thing we see is select into. Now, the syntax of this is you can do select field list into table, whether that's temp table or actual table, from, and then the rest of your clauses. A lot of people do this with temporary tables. So let's say instead of doing a subquery, we want to store the results in a temp table so we can manipulate them later. We'll select what we need into temp table name. Great, it does it. It just does it. The data types will be whatever they are in the base table, and it will only contain the data we need. Seems like a great idea. But the problem comes when you've got a large block of code, we're doing select intos, and then we're seeing that code manipulated later, that table. We'll always use a temp table in this example. The temp table gets manipulated later, some fields get updated, data gets deleted, it gets sucked into another temp table. If something goes wrong with this code, the person coming to look at it, which is probably the DBA, doesn't know what this temp table looks like. It's not declared in the code, so you don't know the structure of it. The only way you're going to know what it is by running the code that creates the temp table, and then you'll go, or you'll have to work out in that block of code that creates a temp table what all the fields are, where they're coming from, because hopefully you're aliasing, and then the data types before you can do any sort of troubleshooting. So troubleshooting is an absolute nightmare. Things like data types, when you do select into, it does take it from the main table, but that may not be the data type you need to join elsewhere if you've got problems with implicit conversions. When you create that table, you can't put any sort of constraints on it. You can't put a primary key. You can't put a unique identifier to make sure that your data is correct. It just throws it in there. You can apply them at a later point, but what if your data's already bad by that point? And then indexes as well. You can index after the fact, but things like a clustered primary key on a temp table is a great thing to have in most cases if it's a decent amount of data. You want to do that when you declare the table rather than doing it after the fact. It's just much more efficient in the code. It's easier to read. So doing select into just takes away your agency to declare this and make sure it's exactly what you need. And it also adds a massive complication in troubleshooting. And that'll come up a lot. A lot of these things are in this webinar are issues that happen when we're trying to troubleshoot. And it slows everything down. And chances are when you're troubleshooting something like this, it's in production, you might have an outage. We want to make that troubleshooting as fast as possible. So we just, all of this, we want to put a little bit of effort in up front to do things properly, for want of a better word, so that when we're in a situation where we need to do things fast, it makes life for everybody so much easier. So yeah, proper table declaration. And please don't use table variables in most scenarios. Temp tables is the way to go. Okay, another thing we see is a query with, in the where clause, where ID in, and then select ID from this other table, maybe some joins and what have you. Logically, that makes sense to read. We want to make sure our ID is in this list of IDs. That makes sense to a human. The way SQL Server works, it's far from ideal and it doesn't scale. So what basically happens is in that subquery, it'll run the subquery, return X amount of rows, whether that's 2, whether that's 1,000,000. What SQL Server then effectively does when it optimizes this query and creates the execution plan is it treats it like you're doing where ID equals ID1 from the subquery, or ID equals ID2 from the subquery, or ID equals ID3 from the subquery. It's effectively turning it into a row-based operation, which SQL Server is a set-based language. It likes doing big chunks of work all at once. By doing this, it's turning it effectively into row-based, which is often poor for performance. And also, once you get to a certain limit, SQL Server will just give up trying to create a good execution plan, and it's not good. It doesn't scale. If it's a few rows and it's always only a few rows, it's acceptable. But do you know the results returned are always going to be a few rows? Because if not, you may come across parameter sniffing issues, and that's where I'm sure most of you know that if you're here, but where a query has an execution plan created for a certain given set of parameters, it's usually a store proc, it uses that for other queries that maybe it's doing a loop because it only returns a few rows, but then you've got a million and it sucks. So yeah, if you did this, it would be not ideal. Now, one of the ways of resolving this is often if it's where ID in this list, that's just an inner join. You might need to be careful about duplicates. You might need to do a distinct list in your subquery, but where ID is in a list is basically an inner join. Where it's not in, sorry, please do excuse me. Where it's not in a list of IDs from a subquery, you could do that as a left join and an is null. You could do a where not exists instead of a not in list. And the advantage of where not exists, or where not is it can shortcut, it can run faster. Alternatively, you could just take the subquery, chuck it into a temp table, but declare it properly, and then use that in the later query. That way, the temp table will have its statistics. It will know roughly how many rows to expect and the variance of that between queries. It just kind of abstracts it a little from the big bulk of the query. So yeah, in with a subquery, we see a lot, and it causes so many performance issues. No lock. A lot of people see this as the magic go faster button in SQL Server. And to understand what it does and how it does it, I'm going to have to speak a little bit about SQL Server locking and blocking and isolation levels. So we'll briefly go through that. Basically, when SQL Server runs a query, if it's a read query, it's going to take out what we call a shared lock on the data it's reading from. And what that shared lock means is, whilst I'm reading this data, nobody's allowed to change it, but anybody else who wants to come and read this data can read it as well. It's fine, like it's not just mine, but please don't change it while I'm reading this data. And that's a shared lock, whether that's on a row, page, table. So you got a reader reading data, other readers can read the data. Now, this process does block writing processes, so inserts, updates, deletes on the row of data that's locked, or the page, or whatever the locking level is. So readers, if they're reading data, will block anybody from writing to the data it's reading. It's locked. That also works the other way around. If a process is modifying data, then it's going to block anybody, including other write processes and including read processes. This is in the default isolation level. This is level 1 here, read committed. So only read committed data, and it allows readers to block writers. That's the default behavior for SQL Server. That's how it's designed. You wouldn't want to read data while somebody else is modifying that data. Usually, sometimes you might not care, but it's good to understand how that works. Now, level 0 on the page here, that's read uncommitted. That is effectively no lock. What that means is, let's say a big writing process comes along. Well, what it means is nobody blocks anybody apart from writes. It means you can read data that hasn't been committed. So let's say we've got a big update query that's modifying a ton of data. You've got an overnight ETL load, say. That's usually the biggest that people have. Like we are nuking a page and recreating it from scratch overnight. What read uncommitted means is, if I'm a read process and I want to read data off that table, I'll read it. I don't care if it's good. I don't care if you're modifying it. I don't care if it's empty. I will go and read data. Now, you can probably understand why that can cause issues. Let's say we're updating all of our users with new, I don't know. If I use a Stack Overflow database as a demo, so let's say we're relinking users to posts or whatever. Read uncommitted and indeed no lock means I'm not going to wait for locks. So I'm going to run nice and fast. I'm not going to bother that you're writing the data. I'm not going to wait for you to finish. I don't care that you've locked the data. I'm going to read it anyway. And the data just gets returned. Now you can get rows returned more than once. You can get rows completely missed. So let's visualize a users table. Let's say my name's Richard Benner and I'm changing my name to Richard Smith. And it's ordered by surname. So I'd be at the top of the list originally in the B's. I'm going down to the S's, lower down the list. If I was currently modifying that data, a read process with no lock could come along, could read me as Richard Benner. The write process modifies me to Richard Smith, and then it reads me again as it gets to the bottom. Same user, same data, but because I didn't wait for that update to finish to change my name, I read it anyway. I read my user twice. Now that obviously can happen with a lot more data. It can have, yeah. It's scary if you're using that data for anything business driven, or if you care about the accuracy at all. You need to really think about no lock, because it's so scary. You could just get absolute nonsense results in certain scenarios. That's why it's fast, though, because it doesn't get blocked. But a lot of people aren't aware of the risks involved with producing bad data. I won't cover the other isolation levels because I'm probably going to run long on this webinar, and I don't want to do that. But repeatable read and serializable are more pessimistic locking levels. So serializable readers can block readers, for example. Like this is my data, hands off. Most people have recommitted. There are separate options called snapshot isolation and recommitted snapshot isolation. We won't cover those a lot. I'll mention them briefly because they can be very useful. Basically, what these mean is when a write process starts modifying data, it stores data in the version store in tempdb and says, right, this is the data I'm modifying. I'm going to store a version from before I started in tempdb in the version store, and then I'm going to go do my work. And if a read process comes along and wants to read that data, you can't read the data that's currently being modified, but you can read the last good data from version store. That's an excellent way of avoiding the blocking problems where writers block readers, readers block writers. It may not block readers and writers. It may not avoid the block of readers versus writers. But the point is, it's a great way of getting around the blocking issue, increasing performance. There is an overhead. You need a version store in tempdb, and keeping the versions of your modifying data does have an overhead. But if you care about your data, but you want it faster and you're on recommitted isolation level, then definitely look into a snapshot or recommitted snapshot. Excellent results from those. So let's move on from no lock. So that was our T-SQL section. Jason, have we got any questions before I move on?
Yes, we just got one from Glenn. He says, in relation to isolation levels and locks, can you discuss versioning, and then in parentheses, allowing you to read last successful committed data?
Yes, so that's recommitted and snapshot isolation. I'll talk about them a little bit more. Yeah, basically the version store is lovely. It's stored in tempdb. It's part of your tempdb database. So it's not part of the user database itself. But yeah, whenever a range of data is going to get modified, whether that's a delete, insert, or update, any sort of DML query, it takes the range of data to be modified, which hopefully isn't your entire database, your entire table, but it might be. Stores it in the version store, and then any read queries get redirected to the last good data. Now, that will be as old as your current write transaction. So you've got an update that takes an hour. You could potentially be reading data from an hour ago. If your updates will take a few seconds, you're reading data from a few seconds ago. Yeah, that's the basics of version store. And I might even do a full webinar because isolation levels are a whole beast to themselves. And I could probably talk for them. Well, I could definitely talk about them for an hour because I'm a nerd. But yeah, that's version store, and snapshot isolation is what that's for. Okay, so let's move on. So obfuscation, and what we mean here is when you're looking at a query, say you're troubleshooting, you're looking at a query. It sometimes might look very simple on the top, but you then find that there's one of the objects you're using depends on another object that does some logic, which depends on another object. So it's about removing code from your immediate view and making people have to go and dig around for it, whether that be when they're making feature enhancements, maintenance, or fixing an issue. We'll go through a few things and it'll become a bit more clear why it can be an issue. So one thing we see in an enormous amount of times is nested views. What this means is you've got a view, you're selecting data from a view, but then that view is based upon that view and that view and that view, which are then based upon another few views, maybe some tables, and then you've got other, and we see these long trees of dependencies on views, views based on views, based on views, based on views. Now, that makes troubleshooting a nightmare because you have to work out where and follow the path, and that's not what you need to do in an emergency. But then also think about the scenario where in one of those queries that's nested 10 deep, somebody makes a change to that view, or any sort of any of the dependencies. That logic is going to flow through everything and change any query that uses this view. Now, views are extremely useful. They are great places for like centralizing code, to make sure that everybody's using the same logic. In like this view does our logic for sales over the past 12 months. Everybody, if you want data for the last 12 months of the sales, then read from this view. That makes sense. The problem is when that gets turned up to 11, and then suddenly we are in a spaghetti nightmare of views and nested objects. I've got a little demo that I'll cover in a second, but to explain why this is an issue. Now, another issue is when you're selecting from your view, SQL Server will obviously, you're running a query, it'll have to make an execution plan. If you've got too many objects, the execution plan can just time out. I can't remember the exact number off my head, but it's a couple of seconds at most. If you're trying to create an execution plan with all of this, SQL's trying to analyze all the code and all the stats going down, it could just give up and just go, I'm just going to run it, which obviously it's very unlikely you're going to get a good execution plan out of that and it actually process in a timely manner. SQL Server just throws his hand up and has done with it. So that could be another issue. Confusion, again, like if you're looking at a block of code, it doesn't tell you it's a view. If you're selecting from an object, just looking at it doesn't tell you whether it's a view, whether it's a table. You have to hover over it. You have to go and make sure that you notice it's a view, and then you have to go and find where that view is. And it's again, when you're trying to do anything that involves that view, it's just going to make everything 10 times longer. It's an absolute nightmare. Another thing we often see is hidden link servers in there as well. Let's say that I want sales for the last 12 months. Okay, I'll select from there. What you don't see is in that view, we're linking to 5 different remote link servers. We've got a complete section about link servers in a second, but they can hide these horrible things which are just going to absolutely tank your performance. Yeah, it's just by hiding all this code away from the troubleshooter, the developer, the DBA, whoever, it just makes the job harder. So trying to be mindful of reducing the amount of nesting we're doing is very much a good idea. What I'll do is I'll just switch to a demo here for this one. So this is the most simple query you can have, right? Select style from I'm a table. Now, SQL Server doesn't know what this is. It's underlined in red. It doesn't know it exists. Invalid object name. The query still runs. Okay. And all this is doing is selecting a list of databases that are in my server here. This is just a local server. I've got a few test databases. It's weird. It's producing them twice. Okay. So what is that? What is that object? Don't know what it is. Most people would go into the table list, go, I'm in master. Okay, let's go and have a look at master. Oh, it's not there. There's no one called I'm a table until you go down and find out it's a view. Oh, look, there's a ton of views here. I wonder what that is. What you can't see here is there's this query here, which is by Michael J. Schwartz, which you pass it in an object and it shows you all the dependencies. So I run this using my thing. Oh, look, it's based on this view, which is based on this view, this view, this view. Oh, look, it's also based on this. There's a tree. So just running this simple query, you can't tell that it's got all of this. Now, for the purposes of the demo, this is just views, but I've seen these hundreds deep, where it's a view with functions in it, with synonyms in it, with all sorts of fun stuff. That's part of the problem here, the fact that you just can't see that if you're abstracting this. And now I know there's a problem here because I've got duplicates, but where's that coming from? I'm going to have to search through 18 views to work out where the problem is here. I mean, I know that it's this view has got a union to this one because I wrote this demo, but in a scenario where I've got this problem with this code, it's producing duplicate data, you could just see it's just making troubleshooting a nightmare. You'd have to step through each one, run it, see if the problem still occurs, and if it's a large query that takes hours to execute, troubleshooting it could be an absolute nightmare. So yeah, it's far from ideal, stacking views. A limited number's fine, but we see some crazy stuff out there. So where's PowerPoint gone? Oh, this is Jumpbox. Okay, so that's nested views. Great idea. For developers, it makes sense. For troubleshooting, maintenance, and feature expansion, it makes things extremely complicated. Scalar functions, this is one of my favorite. And by that, I mean least favorite. So anytime you use a scalar function in a query, and this we're not talking table valued, and we're not talking inline table valued, but scalar functions. Anytime you use one, your query will not be able to take advantage of parallelism. So just to cover what that means, when your query runs, you have a couple of settings in your server, your max degree of parallelism and your cost threshold of parallelism. What this means is every time a query gets executed, it gets given a cost, which is an abstract number at this point. It used to mean something 30 years ago. For now, it's just a number for comparison purposes. If your query is above your cost threshold, it says, okay, you're a big query. You can use more than one CPU core. So let's say you've got 24 CPU cores. It will go, okay, I'm going to go parallel. How many cores can I have? And then it goes to your max degree of parallelism, which might be 8. And it says, okay, you can use it up to 8. And it will go ahead and run. And that basically will split the workload and allow it more CPU, which for larger queries is great. It improves performance. By using a scalar function, you cannot use parallelism. It will always run single threaded, which may be fine for a small query, but again, scalability in larger queries, not good. It tanks performance because you're only using one core. It's just going to take you 8 times as long to execute the query in this scenario. So that's a problem. Another problem we have with scalar functions is that because it's a function, it's treated as a separate transaction to your main query. If you've got a performance issue, you can run a query, you can run it with an execution plan. Your scalar function won't be in there. Your query execution plan's lying to you. So you can have, we've had scenarios where this query performs poorly execution plan looks like it should perform nice and fast. And it's because there's a scalar function in there, which is treated differently, gets its own execution plan elsewhere. And it just makes it invisible to the average troubleshooter. Also, if you were to do something like set statistics IO on, so you can see how many reads and how many writes your query's doing, functions aren't in that either. They've got their own stats, they're elsewhere. So you can say, I'm only doing 8 page reads. Why is my disk going crazy? And it's because you've got functions there that are just munching away, and you can't see them unless you use something like SVWho2 or Who is Active or BlitzWho to see what's happening right now. You might catch the query, but the fact that you're adding this into your code, but you can't see it, again, makes troubleshooting a nightmare. So a couple of reasons why scalar functions are slow as well, aside from serialization and aside from being near invisible in execution plans, is that they are, by definition, a row-based operation. Now, I covered this earlier. SQL Server set-based, not row-based, like a language like C# or whatever. SQL Server likes being given big chunks of table, big calculations, go and do them. Other language prefer to iterate through. I'll deal with a row at a time, and they're fast like that. SQL Server isn't fast like that. Scalar functions they will effectively iterate through each row. They are executed once for each row, and that's not even each row in your result set. That can be each row in your main table. If you're doing like a where clause on that, it's going to have to do your scalar function every time before it then processes and shrinks down your data. That just sucks in SQL Server. I've mentioned troubleshooting. Computed columns is an interesting one. So we've seen it where a customer will have in a table a non-persistent computed column based upon a scalar function. Now that may be first name. Effectively, what you're doing is you're taking the ID from this table, table A, you're going to the users table and returning the first name. Now, that should be done in a join, but that's fine. But it's not fine. That should be done in a join. But the reason why it's a problem here is anytime we select that field from this table, we're going to have to, it's going to run serial. We have to calculate it every time, every row of data. If I'm only searching for people called Richard, then it's going to have to run it for the entire table to return the first name before then filtering out to Richards. They perform badly. Scalar functions, there are certain uses where scalar functions make sense. If you're declaring a variable and then setting the variable to equal the result of the scalar function, that's only going to execute once. Like, okay, fine. You're going to have an issue if it's performing poorly because it's not in your execution plan, but that's only going to run once. That's less likely to be a problem than if we're running it a million times on a million rows of data. So yeah, functions make a lot of sense in languages like C# and Java. In SQL Server, they don't. You can get multi-statement multi-statement inline table valued functions. They're tricky to get right. People often get them wrong. But that is basically treated like a table and is a set-based operation. Just to preface this, SQL Server have recently, in the last version, maybe 2019, 2022, brought out scalar function inlining. The idea being SQL Server can treat a function like a table and do a set-based operation. Now, in my experience, a lot of people aren't on SQL Server 2022 yet. Some people might be stuck on 2016. And it can be a bit, it can make different decisions, and it's not perfect. And that's fine. If you want to rely on Microsoft to get your queries right, you can. Or you could write your code so that it doesn't rely on a certain feature in SQL Server that will behave different on different versions. Suddenly you migrate up into Azure and it treats functions differently up there. It's better just to get it right and try not to use functions. There's not much more I can say about it. I hate functions. They cause so many performance issues, but I'll move on because I could spend the next half hour complaining about them. Okay. Triggers is another big one. I actually had this on a client today. Triggers are set at a table level. You can have insert, update, delete triggers. You can have instead of triggers that happen instead of doing your delete, say. You can have after ones, which after your transaction is complete, it then goes and does stuff. Or you can do on, which will make you wait for that trigger to complete. Now, these, again, completely separate to your execution plan. They are absolutely separate when it comes to that. But let's say you're trying to delete data from a table. Running a delete statement with your parameters is fine, right? But what happens then is if you've got a delete trigger or an on delete trigger on your table, it will then go away and do other stuff. Now, the most recent one I found of this is it was a relatively simple delete, right? But one of the triggers was 1,300 lines of code, which there was a problem. We wanted to fix it right now because it caused an outage. Do I have to read through 1,300 lines of code because this trigger exists? No, I don't want to do that when I want to get the server back up. Why we'd have triggers is often they can be used correctly, but they can go very wrong. And again, it's difficult to detect. It's difficult to troubleshoot, especially in a disaster recovery situation. I'd rather not have secret things happening within my database that I have to go and detect. The only reason we found this is by capturing queries into who is active. We got the query it was running, but it wasn't a query in our statement. I had to search through SQL Server's DMVs to find all code in the system that contained certain strings before we could even find that this was a trigger. It's just, we don't want to be doing this. We want to get servers up. We want to get them performing well. The other thing to mention is that, yeah, if you're doing an on, so on delete, on insert, I'm trying to delete data. It should be simple, but I'm going to have to wait till this trigger fires and does whatever it does, all this hidden magical stuff, before my query will complete. So it's going to reduce the performance of my query, which should be simple, but it's not. And unless you know your code base backwards and you know all these, and you may have been in the same job for 15 years, but you may have only just started. You may be coming in a year ago. You may come in as a consultant. You don't know the code bases. Having these things just it extends the time so much on troubleshooting and just getting your server back up and running. So if you can have if you've got another option that isn't a trigger, definitely consider just not using triggers. They can be fickle beasts. The last one in this section is synonyms. Now, this one's interesting. And basically, not many people use synonyms, but when they do, it causes a bit of a headache. So what a synonym is it's a server object where you basically say, it's basically a pointer that says, you can use me like, I'm going to select from, and then the synonym name. It's an object. It's like a table, like a view. You can select from the synonym. And then that synonym may be called something like table_users. But the whole idea of a synonym is you're renaming an object without actually renaming it. So you may be doing select from table underscore users. What you're actually doing is hitting the synonym called table underscore users because you don't know. And what that's actually doing is calling view underscore users, which is doing loads of other stuff in the background. It's, you don't know. Well, the last time I had this, we were doing, let's say we were doing select from table or select from, and it was a synonym, but it looked like a table. Hit the DMVs, the dynamic management views. It hit sys.tables, not in there. Sys.views, not in there. Sys.objects, it was in there. Object type synonym. So then I had to go to the synonyms and find out where we're actually selecting data from. And yeah, it's another layer of complexity. Like, why don't you just select from the object? And one of those reasons is often, oh, because we've got this code base. It might be legacy. It might just be a monolith. It might just be huge. It's looking for this object. That table doesn't exist anymore because we have to do some logic. So we've got a view and we've renamed, we've pointed it, which makes sense from a purpose of just getting your application up and running and going. What it doesn't make sense of is for troubleshooting. It's often better to search your code base, rename the object it's looking for. Instead of looking for table users, just rename it to view users, and then it's clear that we're selecting from this view over here. The reason this is a problem is not many places use synonyms, thankfully, but it does make things much more complicated when you're coming in blind, maybe new. Maybe you're not a DBA, maybe you're a developer, maybe you worked on a whatever. It just adds a level of complexity that you don't need. Okay, Jason, have we got any more questions about any of those before I move on?
Well, we just had a comment from Brandon on synonyms. He says synonyms are usually used by companies who allow backwards compatibility within databases to make code more portable.
Yeah, and there are use cases, but it just, yeah, it makes stuff a nightmare. What you can do in that scenario, if you can get in at day one, is just use a view from the beginning, and that view might just be select fields from table. But then what you have is you don't have to rename that view when you need backwards compatibility. If it's no longer based upon that table, if the logic's different, you could just point it at the new logic. That is tricky because, again, you need to design around that from ground up. You could retrofit it, but yeah, for the cases of backwards compatibility, it's, yeah, I get it. And for all of these, there are use cases. I may not like those use cases, but there definitely are. Just that they're off. The things we're talking about here are when things are overused or unnecessarily used, perhaps. And plus, I'm not your boss. If you want to use them, use them. But it's things that we see often, or we've seen more than once, that cause problems. So yeah, if it's backwards compatibility, you have to. But yeah, maybe we could just call a view the old table name. So it's the same object. It's table underscore users. It's called table underscore users, but it's actually a view. That's still complicated, but it's a bit less complicated than a synonym. Perhaps. Cool. Nothing else, Jason?
That's it for now.
Cool. Okay. So let's talk through a few other things we've got here. Linked server abuse. Right. Now, linked servers are fine. They are necessary in some situations, not all, but some. What we're specifically talking about here is the overuse of linked servers. We've seen where, for various reasons, people do four-part naming convention of linked servers. And what I mean by that is, when you're selecting from table, you just do the first part. You can do schema and table, database schema and table, or server schema and server database schema object, not table object. And what you can do with that is you set up a link server and you can select data from my other server over there. Say I'm the sales system. I want to pull some out of our CRM. Then, sorry, the sales record system, and then pull something out of CRM. You can select CRM, database, schema, table, object, and pull that data in. Seems sensible. And it's absolutely a feature of SQL. It's been a feature for a long time. What people don't realize is what's actually happening behind the scenes. So just talking about remote query execution here. If you do link server with 4-part naming convention, and let's say I want to run a little query on this remote server and I just want the results. I'm going to join CRM users to CRM sales and find out who's sold stuff in what regions. So I'm going to add a couple of where clauses, what countries we're selling certain products to. If you do this query and use 4-part naming convention, what you'd want it to do is to take that block of code, go to the remote query, run it. So join my tables, do my filters, return me the results, and maybe do some aggregation, I don't know, and return me the results. That's not what will happen with 4-part naming convention in most cases. There are advances to it more recently, but basically what SQL Server will do is go and get those 2 remote tables, pull all of them across the network locally. So massive network, potentially. You got to read it all off disk there, send it over. You're going to have to store it in memory. And then it will do the joins, and then it will reduce down and give you a selection that you need. If you use something like OpenQuery, then that's the correct way of doing link servers. And that will do what we talked about, which will take the query, take it remotely, process it, return the results, not all of the data, just the results that we asked for. So OpenQuery is the correct way of doing link servers. 4-part naming convention is not. But then if you think about 4-part naming conventions, what we see is that people will union multiple objects together. Say I've got a data, I'm a software vendor, a SaaS vendor, and I've got a database for each customer. But because I've got a lot of customers, I've got a lot of servers spread out. I want to return the results from multiple databases on multiple remote servers and union it all together to give me a nice list of everybody's information. Seems fine. If you just do that with 4-part naming convention, you're pulling all of that data from all of those remote servers locally, then giving you your filters. I only care about some subset of users or whatever. So we see link servers abused so often, and they don't perform very well in most circumstances. If you use OpenQuery, it's much better, but a lot of people don't because 4-part naming convention is easy. Now, I did mention on SQL Server 2022, we at SSG, we were running a test on this for a customer, and the behavior's changed. It's actually better at treating queries with 4-part naming conventions as OpenQuery behind the scenes. Sorry. But the problem with that is it's version specific. It's near invisible. I'm not sure SQL Server Microsoft have even announced this or explicitly announced the behavior change. We were running demos and like, no, hang on, this is good. But again, how many people are on SQL Server 2022? Are they going to change the behavior in future? Are you going to write some code which works now on this current version? It gets patched and suddenly it changes. It's much better to rely on the recommended solutions, which in this case is OpenQuery, rather than Microsoft trying to fix your code behind the scenes. It's better to just do it properly in the beginning. Okay, the many database problem. So this is that situation where I've got a database per client. There may not be many. There may not be much data, but there might be a lot of databases. There might be half a gig each, 500 meg, like tiny, but I've got 200 of them. Doesn't seem like a problem. but there can be problems. Let's say you've got availability groups on this database, so you've got the disaster recovery, the high availability, and stuff like that. It takes CPU threads, it takes worker threads to keep those databases in the AG, even if they're tiny, even if they're unused. It's using threads to keep data synchronized across. You've got 200 databases. It's more than one thread per database, so you can use up a decent amount of connections to your server just for maintaining the availability groups, which, if you're having a lot of connections, you can run out. Users can't connect to the database at times. That's real problems. The other issue, or another issue, is context switching. And what this means is you've got 200 databases on your server, and you're going to have people hitting each database. SQL Server having to switch context between databases back and forth. It's one of the performance counters it measures, and that can cause problems. It's often context switching is a victim of other things, but context switching isn't great. It takes extra CPU for it to dump what it's doing and go pick something else in a completely different database. It's just a bit more work for the SQL Server, which you don't want. And then, talking about maintenance as well. Let's say all these databases are copies of each other, just with different data in. You've got to back up 200 databases, which isn't easy if you're in disaster recovery and you're like, oh, I need this particular database, and you're looking at a list of 200 and you have to search through, find the same one. You're doing 200 log backups every time you're doing log backups, every 10 minutes, every hour, whatever. It's just a lot of nonsense. You might have to do it, but it's just complexity that you don't necessarily need. And then I'd hope you're running some sort of index or statistics maintenance, or you're on managed instance who do it for you. But yeah, you're going to have to run that on all your databases. So run if you have to run dbcc check db to ensure you haven't got any corruption, you're going to have to run that on 200 databases. Doing this seems like a great idea, becomes a nightmare pretty soon. I'm going to move on. I'm aware of the time. So over provisioning, we see this more than we'd like to. And this can mean a couple of things. If you're on a virtualization layer, you have a host, and then you have a few tenants on the host. What often happens, and what some tools do by design, is you can over provision hardware. So let's say I'm on this laptop, 24 cores, I've got 64 gig of RAM, right? I want to host some SQL servers for other people. Each one of them would like 8 cores and 20 gig of RAM. Okay, so I've got space for 3 of them. But I realize that each of these tenants isn't using all of those resources at the same time. Why couldn't I stick a couple more on there? Because I've got CPU cores sitting here idle. They're not using the memory they've said they wanted. I'll just stick a couple more on there. I'll stick another 3 on there. I'll double it. So I have 24 cores and 64 gig of RAM to give. My tenants are asking for 48 cores and 120 gig of RAM. I might get away with that if they all stay if they're not all maxed out. I get away with that. Fine, it's cheaper. The problem happens when they're not all quiet. Let's say 3 of my servers suddenly go, right, okay, it's year end. We need to do a load of processing of all of our data. Go. They're all using all of their CPU, all of their RAM. The other 3 just don't have resources. We're going to be fighting over who gets my system resources. Now, from within each of the tenants, you probably don't know this. If you only have access to the tenant and not the virtualization layer, I've had this before. Go into a server. Okay, it says it's got 24 cores and 64 gig of RAM, but it's hardly doing anything, and the CPU is maxed out. That's because of soft provisioning like this, where things are over provisioned, and it turns out that another server on the same host is using everything. It's using all my resources, but you can't tell that within SQL Server. You can only get that if you know about the host and all that sort of fun stuff. So it can be a problem, and that's effectively noisy neighbors, where you're on a host with another tenant on there that is using a lot of resources. There's just less available for you. SQL Server licensing are expensive. We don't want to throttle how many resources you can get. You're paying to license 8 cores on each of these tenants, and that's standard. It's $2.5 per core. Enterprise is around $7 per core, I think. So you're spending between 20 and 56 grand on licenses for these, and yeah, you don't want to do that. You want to try and thick provision stuff. The other type of over provisioning is, let's say I create an AWS box, an EC2 instance. I've worked out I need 16 cores and 48 gig of RAM, whatever, for my SQL Server. I go and create that, but then I'm going to install SSRS. I'm going to install SSAS. I'm going to install SSIS on the same box. I've got these other features on there. So I've got enough resources for SQL Server, but because I've got multiple features of SQL Server on this box, I'm going to struggle, because SSIS is going to run at 6 a.m. and do some sort of ETL, or SSRS is going to run and give salespeople their reports all day. Stacking these means you're going to struggle for resources. And it's similar if you've got multiple instances of SQL Server installed on the same box as well. So you can stack a lot. You could, like, hundreds if you want, but that'd be insane. But if you have multiple instances of SQL Server, then you have to look at a host level, at the Windows level, to understand which one's using which resources. From within each SQL Server, you can't see that, and you might not have access to the Windows host to work out what's using what, and suddenly one takes resources from the other. It's a world of pain. The ideal for SQL Server is dedicated host, just SQL Server, and give it the resources it needs. That's the ideal. I understand from a cost perspective, that's not often what happens, but you're licensing this, get your value out of it. Okay, I'm going to go through the last couple of slides here. So keeping connections open. This is a thing that we see from applications and application developers is, let's say I'm an app developer. I need to do some stuff in the database. I'm going to open a connection, do some stuff. I just need to do a bit of processing on that. So I'm going to do that. And then I need to do I'll send another query to the SQL Server, receive it back. I'm going to do some more stuff. I'm going to write that to the SQL Server now, send a query back, close the connection. That seems to make sense, but that doesn't scale. You've got a maximum number of connections, 32,000. If everybody's doing that, you get busier and busier. People are holding. During that transaction, you might have only needed the connection open for a few seconds, but it takes 30 seconds because you're doing some more processing and stuff in the application. You're quickly going to run out of connections. What you'd want to do and try and get into the habit of is connect to SQL Server, run your query, disconnect. Do what you need to do. Connect to SQL Server, run your query, disconnect. Do what you need to do. Open your connection, send your data, disconnect. That way you're holding the connection for only when you need it, and you're not going to start running out of connection threads. And again, yeah, this is a scalability thing. It's a good habit to get into, and it's just going to allow you to do more concurrent work from the application. Debug mode is the last thing we'll talk about. If you can, when you're developing new code, add a debug mode. Now, what this is you set a variable at the beginning. It could be a bit called debug or whatever you want, which is set to 0 normally, and nothing happens usually. But throughout the code, you have to modify your code that if debug equals 1, then maybe just print the code I'm going to run rather than actually go and run it. This becomes very useful when you're trying to troubleshoot. I was working on some partitioning, and it was doing lots of dynamic SQL, which is all good and fun, and it was using lots of subqueries, subprocs, but effectively, the fact that debug mode was here, I could set debug to 1, and it could go through, and instead of actually doing all the work and modifying data in the production environment, it just gave me the code that it wanted to run. And that way, me as a troubleshooter, I can go through and read it all, and oh, there's a syntax error, or oh, there's a hard-coded value, or whatever. But again, that was in a production environment. I don't want to be having to like go through and comment out code and just give me the code you were going to run, or trying to work it out. By adding in this debug mode from the beginning, me troubleshooting saves so much time. I could see what it was near instantly. Yeah, so that's, if you can get into the habit of debug mode, that's great. So conclusion, many traps, we've talked about them all throughout here. You could spend a little bit of time up front, which people don't like doing, but the payoff for that is when you're up to your neck in it, you've got options. It's not going to take you as long to fix an issue. Ultimately, you're going to get prod back online sooner. What I would suggest is have a good think, or go away and check if you've got these problems in your environments, because I'd be impressed if you don't have any of these. Okay, so our next webinar is on May the 15th. It's called Understanding TempDB. It's with Scott Klein, who's one of our senior consultants here at SSG. Fascinating talk. I highly recommend. You'll get an email after this with a sign-up link. It's going to be good. Okay, have we got any final questions, Jason? I think we're just about at time.
No additional questions. I have just put in the chat a link to register for that May webinar if you want to take action now. As Rich mentioned, we'll be promoting that in emails, so you don't have to worry about missing out on any information. And of course, we will share a link to this video, this webinar, and appreciate everybody joining us and sticking around for a couple extra minutes. Appreciate your time, Rich. I think
Sure.
everybody's been richly informed. No pun intended. No pun intended.
Yeah, just to clarify, Mike, I've just seen your question. Yeah, it will be on YouTube, and you'll get a link to this video.
Yes, absolutely.
Cool.
All right. Well, thanks everybody. We'll see you again in May 15th. Thanks.
Thank you.